Yeah, so good evening everyone and welcome to this next class of this probability. So this will be our probability session 2 and in today's class we are first of all in the last class we have discussed the basic terminologies related to the probabilities, that is random experiment and sample space, event and types of events, and classical definition of probability we have already discussed. In the classical definition I told you that the required probability will be nothing but the favorable outcome, right? Favorable outcome f dot o upon total outcome, or we can say sample space, right? So this was the nothing but the probability according to the classical definition. And one of the question in the last class, one student has asked that why are we saying that random experiment if you already know the outcomes? But I said that for tossing a coin, suppose that for one or two times you might be knowing the probability, right? But suppose that if you are tossing the coin 10 times, 20 times, 30 times, like that, right? In that case the outcome will be totally random, right? These are all probabilities only, right? We are not sure that they will definitely come or no. We are also predicting that the probability of coming head is 50%, or probability of tail is coming as 50%, right? So when the number of number of events tends to increase, this will be called as the random experiment and the sample space will be, we already saw that how to find out the sample space for a random experiment. Okay, types of events we have already discussed, and now in this class we are going to discuss about the addition theorem of probability, and then we will discuss the De Morgan's law. This is going to be a real start of this chapter, right? And we will do some questions from the pyqs also, so be focused on this. Let's start. So first of all we are starting with the question. The first question is now, yeah, I forgot to mention that the question now will be clubbed with the PNC also. PNC means permutation and combination also, right? Because probability, in the probability PNC has a great role, right? If you are weak in PNC, please revise that. So here we are starting with this question. Letter of the word regulations are selected at random. Find the probability that exactly 4 letters are between R and E. Okay, so between R and E, try this if you want. I'm giving you 1 minute, or let's say 20 second, 30 second. In the PNC chapter, if you remember, this question is usually we have done. Okay, so let me write here. So regulation is the word. Regulations. How many letters are there? 3 and 3 6 and 4 10, right? Total sorry, 1 second. 4 4 8 and 3 11. Yes, 11 letters are there, right? So in total 11 letters are there. So what are the total number of possible arrangements that can be done? Total possible arrangements. Total possible arrangements. Anyone? Total possible arrangements for the 11 letters. 11 factorial actually. Okay. Yeah. So because 11 places are there, and you have to arrange them on the 11 places. So of course we can say that here repetition is not allowed. So if you have chosen one letter initially, then second letter, for the second letter only 10 places will be there. So for first letter, how many places, or we can say how many possibilities are there for first place? Obviously 11, and then 10, and it will go up to 1. So when you multiply all of them, this will be coming as what? 11 factorial. Is it fine? Okay. After that, this is not the favorable outcome, right? This is the total possible arrangements, or we can say this is our sample space, or we can say total outcomes. So this is our 11 factorial. Okay. Then next it is asking, they have given the condition that find the probability that exactly 4 letters are between R and E. If you see 1 2 3 4 5 6 7 8 9 10 11, so these 11 places I have fitted here. Okay, I have written here. So it is already saying that key 4 letters should always between R and E. So suppose that if I am saying R is here, okay, and E is here, so you can see that 4 letters are between these 2 letters. Okay, but is this the only possibility? Is this the only possibility? You will say no. Why? Because it may also happen that R is shifted to this place, then E will be shifted to this place also. Are you getting this point? So first of all, let me arrange this. Let me arrange this. How to arrange this? Hmm. So you know that this R and E, they can also shift their positions, है ना? How E can come here also, R can come here also. So there are two possibilities for that. So we will multiply this by 2. All right. Then how many such conditions can happen in which the 4 letters will always between R and E? 1, 2, 3, 4 letters are in this case. You are already saying. Then R and E can come like this. Okay, suppose that I am placing one more time here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I am saying that E is here, and then 1, 2, 3, 4, and R is here. This is the second case. Okay, this is first. So in total, how many possibilities you can get? In total, you will get 6 possibilities. Okay, when you see that, you will get the 6 possibilities. Is this thing is getting cleared or no? Up to here. Just let me know. So we have to write all possibilities. Okay, yeah, good. Now, one more thing is left. What is that? You said that ki, sir, 2 letters are already fixed at one positions. But what about the other 9 letters? What about the other 9 letters? They will also arrange themselves in how many ways? They will also arrange themselves in how many ways? 9 factorial ways. So this will be multiplied by 9 factorial also. Okay, this 2 has been used because R and E can switch their places. We have to satisfy the condition always that 4 letters should always between them. It is not, we are not bothered about that whether R should come first or E should come first. Okay, R can also come first, E can also come first. Okay, so 4 letters between them. So 2 possibilities for R and E exchange positions. 6 possibilities that 4 letters always between R and E. So we can write like this. They can shifted R here, E here, then one more position is shifted, and then rest of the 9 letters can also arrange themselves in 9 factorial ways. So total favorable outcomes are 2 into 6 into 9 factorial ways. So let me write on the next page. So favorable outcomes will be equal to 2 into 6 into 9 factorial, and total outcomes, so we have already calculated, total outcomes will be 11 factorial. And by the classical definition of probability, you already know that required probability, okay, I'm just writing P here, required probability will be nothing but favorable outcomes upon total outcomes. So what is that? 2 into 6 into 9 factorial divided by 11 factorial. Okay, and 2 into 6 into 9 factorial. 11 factorial can be written as 11 into 10 into 9 factorial. So this can be removed directly, and finally you will be getting this is what, 3 and this is 5, so 6 by 55. That is our answer, B option. Okay, this is how we have to do. So as I said, ki P and C should be revised by you. Okay, and this is important in this case. All right, here only I'm just asking you a concept, little concept. I think it is clear now. So the B is the answer, right? I'm asking a little concept here. Suppose that n number of points are given to you. Okay, suppose that n number of points are given to you, and someone has asked that find the number of triangles that can be made from these points. Suppose that n number of points are there. So how many points are required? How many minimum points are required to make a triangle? 3. Minimum 3 points are there. Okay, suppose that the question is already saying that the points are non-collinear, right? They are not lying in the line. So total number of triangles that can be made is nothing but NC3. Selection. Okay, we are doing the selection. Arrangement is different thing. Selection is different thing. Here we don't have to arrange the points. Okay, we have to select the points to make the total number of triangles, right? Okay, so the next question is based on this uh, this property only. See the JEE Main 2019, they have asked this question. It is saying that if 3 of the 6 vertices of a regular hexagon are chosen at random, then the probability that the triangle formed with these chosen vertices is equilateral as. Going to give you the time. Okay, try this. This can be solved. Okay, how many vertices are given? Vertices means you can consider that the points are given, right? So total vertices are given here. Okay, let me change the color here. The total vertices are given here 6. Okay, regular hexagon is there. So how many triangles can be made by these 6 points? The number of triangles is equal to 6C3. Okay, but what is this? This is the total number of outcomes we can get. Now, see, total number of outcome we can get from these 6 points is 6C3. That is total number of triangles we are making. But the question has given a condition so that we can find out the favorable outcome. What is that? Probability that the triangle formed with these chosen vertices is equilateral. Now we have to show that whether these are equilateral or no. So for that, that is our favorable outcome. Okay, we have to find that whether whatever the regular hexagon is given, that will have how many equilateral triangles. So suppose that if I'm saying, let's say this is the hexagon. Okay, this is the regular hexagon, let's say. So now vertices are given, right? Vertices are given. These are the vertices. And now it is saying ki how many equilateral triangle can be made. So let's try to join the edges. Okay. Yes, someone want to say something? You can tell how many triangles we can get equilateral triangle from this. Yes. Hmm. Yes. Answer is option A. But how many equilateral triangle you will be getting? Are you sure? Yes. 2 equilateral triangle you'll be getting. Which? Yes. Exactly. Okay. So only 2 triangles has been made. So number of equilateral triangle will be two only. So our answer will be what? This is our what? This is our favorable outcome F dot O, and this is our total outcome T dot O. So therefore, according to the classical definition, probability will be nothing but favorable outcome upon total outcome. That is nothing but 2 upon 6C3. And formula, I think if you remember, NCR formula, n factorial divided by n minus r factorial into r factorial. So when you solve 6C3, it will be nothing but 20. So 2 by 20, and that is 1 by 10. First option. Okay. All right. So let's go to the next question then. So for this, the answer is A option, 1 by 10. Next question. Just a second. Someone has joined. All right. So this is the next question, and this has been asked in AIEEE 2010. And the question is saying that an urn, okay, urn you can consider a container, right? An urn contains 9 balls, of which 3 are red, 4 are blue, and 2 are green. 3 balls are drawn at random without replacement from the urn. The probability that 3 balls have different colors is, we have to find out that probability of all the 3 balls should be different in colors. Acha, what is the meaning of this without replacement? Anyone here? Correct. So once the ball is taken out from a urn, it is not again put it back. All right. So suppose if 9 balls are there, okay, and I took one ball out, so that one ball has not been put it again into that container or urn. So the remaining ball will be 8 only. Okay. Now I'm writing here. Anyone got the answer? You can tell me. 3 balls are red, 4 are blue, and 2 are green. Okay. Now there are two things here. If I ask you that what is the probability that one red ball is selected, can anyone tell me? One red ball selected out of the 9, what is the probability? Okay, correct. So probability of red ball, one red ball is selected. One red ball selected. Probability will be 3 by 9. What about the blue one? If I said that I have randomly drawn one more ball from that box or urn, then what will be the probability of blue ball? Exact, exactly. So now this will be 4 by 8. Okay, because 9 out of 9, one ball has already been removed. Red ball has been already gone. Now probability will become, total ball will become 8 only. Similarly, when we say that what will be the probability of a green ball, it will become 2 by 7. Yes, but there is another way to solve this also, which will give you the same answer. Okay, but let me tell you how. Okay, so what should be the total probability for this total probability, or can we say favorable outcome, will be nothing but 3 by 9 into 4 by 8 into 2 by 7. Okay, when you solve it, it will become 3 by 3 1 by 3, and this is 2, and this is gone. 1 by 21 is the answer. C is the answer, right? But there is a other thing also we can find with the help of combination formulas also. Okay, so what we say with the classical definition, we say that first find out the favorable outcome. Favorable outcome. What are the favorable outcomes that we need? If we are drawing 3 balls, one should be one should be red, one should be blue, and one should be green. So how many 3 reds are there, right? And 2 blues are there, and 2 greens are there. Sorry, 4 blues are there. So if I say कि one ball has to be selected as red, so it means you are saying 3C1. That means one ball has been selected from out of the 3. Then here addition is not possible, right? Why? Because one after the another you are finding, you are drawing out the ball, so multiply will be needed here. So 4C1 after that, because when you draw the next ball, that we need that it should be a blue ball, so 4C1. Then the next ball should be a green ball, so 2C1. However, this will give you what? Again 3 into 4 into 2. Okay, that will be nothing but 24. What about the total outcomes? What about the total outcomes? So total outcome is that 3 balls have been drawn out of how many balls? 9 balls. So total outcomes will be nothing but 3 balls have been, yes, 3 balls have been selected from 9, that is 9C3. That's it. Find out the probability by this method also. That will be nothing but 24 upon favorable outcomes upon total outcomes. So 24 upon 9C3. When you calculate this, it will come again as 1 by 21. Sorry, not 1 by 21. 1 second. What did we done? Yeah, 2 by 7, right? Yes, 2 by 7. 2 by 7. 1 second. In the first, I think, just a second. In the first part, I think we did the mistake. Multiplied with the 3. 2 is already there. 4, 4 2 is 8. 2, 2 is gone. What we did? For 6, correct. We have to multiply it with the 6, then yes, that's how we'll be getting. Okay, however, you can skip this method if you want directly. Okay, or you can multiply that with the 6, you will get the same answer. All right, someone has joined, just a second. Hmm. So this second method will work here. I think we are missing something in the first one. 3 by 9, 4 by 8 is fine, 2 by 7 is fine. Without replacement, it is given. 4 by 8, 3, 1 by 21. How much it was coming? 1 by 21, right? Hmm. Correct. So if you multiply that with a 6, you will also get the same answer, right? 2 by 7, 2 by 7 is the answer. 2 by 7. This is 2 by 7. And this is also coming 2 by 7. So 2 by 7 will be the answer, first option. All right, next. Next is odd against and odds in favor of an event. Okay. So suppose that it is given कि if an experiment results in a total of m plus n outcomes. Okay, as we discussed already कि what are the total number of sample space, that is nothing but the total possible outcomes. So let's say we are saying m plus n possible outcomes are there which are equally likely. What do you mean by equally likely? As I said earlier, equally likely events which are having the uh, equal chances to occur. Okay, and if m outcomes are favorable to an event A, while n are favorable to, while n are unfavorable. Okay, so suppose that the event A is happening. Let me change the color. That event A is happening, and for that m outcomes are favorable while n are unfavorable. Okay, so that will be giving you the, like this, odds in favor of event A. Odds in favor of event A will be m by n. This is favorable divided by unfavorable. So that will be called as odds in favor, and odd against will be reverse, n by m. Okay, so the probability if you find out odds in favor of event A, that will become nothing but p of probability of A is equal to m upon m plus n, right? Any doubt up to here, anyone? The example is given here, right? Odds in favor of event A is given as 2 is to 5. Then find the probability of event A. That will be nothing but simply 2 upon 2 plus 5, that is 7. So basically odd in favor is giving you the different chances of two, or we can say uh, two things in an event, that is favorable as well as unfavorable outcomes. Okay. Acha, you must be knowing that total outcome is nothing but favorable outcome plus unfavorable outcome, right? And that's where we are finding out this also, right? M plus n is basically mentioning you here, that is the total possible outcomes or sample space. Okay. Next, addition theorem of probability. So in when the two events are happening, okay, let's say A and B are the two events associated with an experiment, then we are going to use the set theory here. Okay, we are going to associate the set theory to the probability. So what is that? In the set theory you might have studied n cardinality of A union B is equal to cardinality of A plus cardinality of B minus cardinality of A intersection B. The same follows for the probability also. Okay, but these were the numbers. Okay, these were the numbers actually, but this will be the probability. Okay, that means they may be in the this will be in the fraction. So if A and B are two disjoint events, okay, what is the meaning of disjoint events? That means nothing is common between them. Nothing in common between them, disjoint events. That's why it is said A intersection phi is, sorry, A intersection B is phi. So if A intersection B is phi, so what do you say about the number of elements of A intersection phi? Sorry, A intersection B. Number of elements will be 0. Okay. So in this case, the probability will be counted as 0 only. Right? Probability will be counted as probability of A intersection B will be 0. And further, this formula will be modified because this part is 0 already. So this will become P of A union B, that is probability of A union B will be equal to PA plus PB. So sometimes in the question we are going to use this directly. Okay, they can ask you like P or B, so sorry, probability of A or probability of B, like that. So we will find out accordingly this by this formula. If they will be giving the disjoint events, otherwise if they are not giving the disjoint events, then we have to understand the problem that whether the two events are unrelated or no. Okay, but that we will understand by the question. So how to prove this? You can see number of elements of A union B is equal to number of elements of A plus number of elements of B minus number of elements of intersection B. This formula we already know. Yes, someone has raised the hand. Yes, tell me. For the disjoint events only, yeah. This will be this we will understood by the example only, right? Okay. Hmm. So as I said that this is the formula when you divide this total expression by sample space. Okay, or we can say the cardinality of sample space or the total number of elements of sample space. So in this case, this will become the probability of A union B. Okay, what is this? Favorable outcome upon total outcome. Favorable outcome upon total outcome. Favorable outcome upon total outcome. Okay. So in general, this formula will be PA union B is equal to PA plus PB minus P intersection B in general. Alright. But if A and B are two disjoint events, then PA intersection B will be 0. Right. Next part. Now there is a note point here. What is that? It is saying that if you want to find out the maximum value of A union B, what should be the maximum value of A union B? Of course, when this negative part is 0. When this negative, because we are subtracting this part now. So when this part is 0, we will say this will have a maximum value. Of course, the maximum value is nothing but probability of A plus probability of B. Or we can say 1. Okay, because 1 is a maximum probability that can happen for a event. So whichever is minimum, it is given, whichever is minimum. However, A intersection B minimum, its minimum value can be what? 0. Its minimum value will be 0 only. So, or we can say PA plus PB minus 1, because PA plus PB is giving you the total possible probabilities. Okay, and then when you subtract minus 1 from it, you will be getting the minimum value of this PA intersection B. Alright, you can understand here. You said that now we are talking about the intersection. Now PA intersection maximum value of A intersection B can be either probability of A or probability of B. How? See here in the Venn diagram. If you see here, just a second. If you see here in the Venn diagram, what could be the A intersection B if you find out? A intersection B means the common part between A and B, and that will be nothing but this one only. Similarly, in this part, that will be nothing but this one only. I think they have given us both the same. It should be like B and A like this. Okay, they have given both the same. Alright. So can you see कि either it can be maximum value of intersection portion can be either the probability of event A or probability of event B, whichever is minimum. This is the case. That's why we are finding out the maximum value. Similarly, okay, so we can say that minimum of either PA or PB. We can say either minimum of PA or PB. Similarly, A union B minimum portion. Okay, let me rub this part. The minimum portion of A union B, the minimum value of probability of A union B. So in this case, if you find out A union B, what will be that? This is B. Okay, this is sorry. This is B. This is A. Okay. Huh. So if I ask that, what is the minimum value of PA union B? PA union B, if you find out here, that will be nothing but the both the portion. We will consider the both the portion, and that will give you nothing but PB. In this case, it will be PB, and in this case, it will be PA. Everyone is getting this portion or no? So in this case, we are getting the maximum of PA and PB, है ना? Maximum portion of the whole event A or the whole event B. So that's why we are saying union part of, or we can say probability of A union B minimum will be equal to the probability of A, or here we should write or probability of B, whichever is maximum here. So maximum of PA comma PB. Okay, this point is clear, everyone? Next we are going to have a question. The question says that if A and B are events such that probability of A union B is equal to 3 by 4, probability of A intersection B is equal to 1 by 4, probability of A complement, this is complement, okay, this is complement. It means that the same thing that you studied in the set theory. There you are subtracting from the universal set, but since if you are asking the probability of A bar, that will be nothing but equal to 1 minus probability of A. Okay, because total maximum probability can be 1 only, and when you subtract this probability of event A from that, you will be getting the complement of probability of event A. So can you tell me what is the answer? Anyone? Okay, so let's solve this question. So we have been given A union B portion. Okay, we have to find out A complement intersection B value. Now for this, again, as I said, set theory is must. You should know about the Venn diagram. You should understand what is the meaning of this A intersection B, a complement of intersection B. So let me tell you, if you know about this A and let's say this is B, all right. So first event is saying, okay, first of all let me draw here. This is, let's say, A, okay, and this is B. So first it is saying that complement of A will be except A every portion. Complement of A means except A every portion. Sorry, that common portion will not be there, right? I have drawn mistakenly. That common portion will not be there. Okay, except A every portion. Then you are saying that intersection with B. If you do the intersection B with B, can you see that you will be getting this portion only? I'm just drawing this with the green color. If you see green color, okay, this is not visible. Black color, this one, this is only the common portion. So you will be getting only this portion. Yes or no? This is A, this is B. Getting this point? So how to write this B? This is nothing but only B. How to write this B? You can say the number of elements of B minus number of elements of A intersection B. That's it. Isn't it? But we need the probability. We need the probability. So this is what n of A intersection B. So we need the probability. What we'll do, we will divide by the sample space. That's it. So number of elements of A intersection B divided by number of elements of sample space is equal to number of cardinality of B, we can say cardinality of sample space minus number of elements of A intersection B upon cardinality of sample space. Now this will become nothing but the probability of A complement intersection B is equal to probability of B minus probability of A intersection B. That's why I said if you are good enough in the set theory, this is going to be very easy portion for you. But the practice should be done by you. Okay. So this is the thing I have explained you. Now you just need to find out the probability of B, and you just need to find out the probability of A intersection B. I think that is given already. It is already given. It is already given. The probability of B you have to find out. And for that I just gave you one formula. Okay, so let me go to the next page. So we have to find out the probability of B first. That is our requirement. So for that we are going to use the formula probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So union and intersection is given. Probability of A is not given. So probability of A, if it is not given, we know that probability of A plus probability of A complement should be nothing but equal to 1 only. So probability of A will become simply nothing but 1 minus probability of A complement. So 1 minus 2 by 3, that will be 1 by 3 only. So that's it. Put the values here. 1 by 3 plus probability of B we have to find out minus probability of A intersection B is given 1 by 4, and this is given as 3 by 4. So 3 by 4 plus 1 by 4 will give you 1 only. 1 minus 1 by 3, 2 by 3. So you will get probability of B as 2 by 3. This is not the answer, right? The answer will be, now we'll find out the answer. In the last slide I have written here PA complement intersection B. So sorry, P of A bar intersection B. 1 by 3. Okay, let's calculate. PA intersection is nothing but PB minus complement intersection B, PB minus PA union B, na? Sorry, A union B or intersection B, yeah. So this will become 2 by 3 minus intersection portion is given as 1 by 4. Take the LCM, you will get 12 here, and then 6 minus 3. So what is this? 12, 4 to the 8, sorry. 4 to the 8, 5 by 12. That is the answer. Okay, first option. Is that clear? Now the next is De Morgan's law. Yes, in the set theory also we discussed that De Morgan's law, and here also it is going to play an important role. Alright, so let's understand the De Morgan's law. Answer A is the for this. De Morgan's law. What it says? It says that the probability of A union B of whole complement will be equal to probability of A complement intersection B complement. This we can prove by the set theory also, or we can say Venn diagram also. If you remember, we have also proved that. So let's see. So you are saying that first of all A union B, you know that A union B is nothing but this portion. This is A, this is B. Okay, but we are discussing the A union B complement. So A union B complement will be nothing but except A union B every portion, except A union B every portion. This is what nothing but A union B of whole complement. Now let's discuss this right hand side part. A complement. Okay, first of all I am drawing the A and B here like this, and then I'm saying A complement means except A every portion, except a every portion. So except a every portion means like this, right? Then we have to add here. What we have to add? We have to add the, sorry, we have to take the common portion basically, not add actually. So let me draw that differently. Second portion is, we are saying b complement. So b complement means except b every portion. Let me draw with a different color. I'll just explain you one first one, right? Second, you will already automatically let understand, right? Second one is also similarly you can prove. So except b, this will be the possibility. Now you can see what is the common portion between them, because we have to take the intersection between them. Take the intersection between them. If you take the intersection between them, you will be getting like this, the same thing that you are getting in the left side. Okay, this is your a and b, and the common portion between both the part is nothing but the outside portion, except the a union b outside portion. Okay, understood this? So do revise the concept of Venn diagram after this session. So this is the same thing that we are saying, or and this is also representing the same thing. This is the first theorem, this is the second theorem. So second one is saying that a intersection b, where the whole complement will be equal to probability of a complement union b complement. So it is like the intersection, the union is interchanged into the intersection, and the intersection is interchanged into the union. You can understand like that, and the complement is already there, of course. On the basis of this, we will do the question. Okay, let's have a question here. The question is saying, in a class of 60 students, 40 opted for NCC, 30 opted for NSS, and 20 opted for both NCC and NSS. If one of these students is selected at random, then the probability that the student selected has opted neither for NCC nor for NSS. Acha, what do you mean by this neither? Anyone? Neither, nor. No, just basically you can say कि neither, if they are saying neither for NCC nor for NSS, means definitely, definitely complement portion is there, right? So of course they are asking A complement intersection B complement. So by studying the question also, you must understand what they are asking. So they are asking probability of NCC complement intersection NSS complement. How do we understood this? Because it is saying only two peoples are there who are either choosing NCC or NSS. Okay, neither for NCC nor for NSS. Then we have to find out the student who are sorry. The probability we have to find out that selected student has opted neither NCC nor NSS. Now, can we use directly the De Morgan's law? We just understood that from the De Morgan's law. From the De Morgan's law, we just understood that probability of A intersection B of whole complement is equal to nothing but probability of uh, probability of A complement union B complement. Okay. So yes. So what should we do then? Anyone have any idea? What is given in the question? Of course, tell me. Okay, total probability is 1, correct? Mm-hmm. Mm-hmm. Mm-hmm.
NCC. हाँ,
Correct. Correct. That is the way. That is the way. First, we are going to write the probabilities of all the students who are. Answer is 1 by 6. Correct. The students, first we are going to find out the write the probabilities of student who is opted for NCC. Total student is already given 60. So it is like more or like they are giving you the total outcomes. They are giving you the favorable outcomes for what? For NCC. So probability of those students who have chosen the NCC is nothing but 40 by 60. So how much it is? 2 by 3. Similarly, probability of students who has selected opted for NSS. How many students are there? Favorable outcome 30. Total outcomes remain same. That is 1 by 2. Then it is also given and 20 opted for both. Both means they are saying about the common portion. Okay, both means they are saying about the common portion. So they are saying ki probability of NCC intersection NSS is given as, just a second. Probability of NCC intersection NSS. This is given as what? How many students? This is given as 20 students, right? So 20 is favorable, 60 is total, so this will be nothing but 1 by 3. So now we have PA, PB and PA intersection B. We need this value. Just look at carefully here what we are doing. Can we write probability of complement of NCC intersection complement of NSS is equal to nothing but probability of NCC union NSS of whole complement. Okay, this bar can also be represented by the complement, or that C can also represent the complement, right? Don't confuse in that. Bar is also the same thing. Now, what is this? If you consider that, let's say this is PA bar, and if I want PA, how do we write that PA? 1 minus PA bar, or sorry, PA bar will be nothing but 1 minus PA, right? So simply we can say it will be nothing but probability of NCC, but remember that here union is used, so union will we will be using the union again, same thing, right? So probability that will be nothing but 1 minus P of NCC union NSS. Now we don't have this value NCC union NSS, but we can use that formula, है ना? We can use the formula to find out the NCC union NSS, because everything is given. P NCC is given, P NSS is given, and P NCC intersection NSS is given. So simply add them and subtract this 1 by 3. Alright, so I'm writing here only. You can say that this will be nothing but probability of, in the whole bracket, probability of NCC plus probability of NSS minus probability of NCC intersection NSS. Okay, let me write on the next page. So we are getting probability, sorry. So we are getting probability of probability of NCC complement intersection NSS complement is equal to 1 minus probability of NCC plus probability of NSS plus probability minus probability of NCC intersection NSS, right? Just put the values and you'll get the answer. 1 minus NCC, probability of NCC is given as 2 by 3, NSS is given as 1 by 2, and this is 1 by 3, I guess, na? So you are getting 1 minus 2 by 3 plus 1 by 2 minus 1 by 3. 2 by 3 and minus 1 by 3 will give you 1 by 3 only. 1 by 3 plus 1 by 2 will give you 5 by 6. So that means it will be 1 minus 5 by 6, that will be 1 by 6 only. This will be the answer. Okay, and if you want to represent that on the Venn diagram, let me represent that on the Venn diagram also. So they are asking that neither of them is possible. It means these are, let's say, NCC student and these are NSS students who are chosen. So neither of them means what? Neither of them means the except the union portion. Except the union portion, every portion will be there. Except the union portion, every portion will be there. So this is the required region. Okay. Let's go to the next part then. Now we'll understand the addition theorem of probability. Answer is, what is this answer? 1 by 6, no? Haan, so 1 by 6 is already given. Yeah, correct. Okay, next is addition theorem of probability. Suppose that 3 events are involved now. So 2 events, so it is easy, right? Not very easy, but still, if you do the practice, it can be achievable, it can be done. But in the 3 events, there is a problem, right? So for the 3 events, let's say suppose these are associated with an experiment, then the probability of occurrence, at least here the word will play an important role, right? You must understand, of at least one of A, B or C is given by. At least means union, simple. If it is saying that at least one of them, it means union. So P A union B is nothing but probability of A. The formula is same, right? Just like in the set theory, that formula was for cardinality. Here this formula is for probability. That's it. The probability of A plus probability of B plus probability of C minus A intersection B, B intersection C, C intersection A, and then lastly you will add the common portion between all of them. Okay. Then next is probability of exactly one of A, B, C occur. See, earlier I said at least means minimum one of them should occur. Maximum all 3 can occur. But exactly means exactly one should occur. Either B will occur or A will occur or C will occur. Exactly. Okay. So in that case, what is the probability? Probability of A plus probability of B plus probability of C minus twice of A intersection B minus twice of B intersection C minus twice of C intersection A plus 3 times of A intersection B intersection C. Alright. So this is the way we will find out the exactly one. You can see the diagram also. In the diagram they have been given. So exactly A means they are asking, let me tell you with the Venn diagram. So exactly A means they are saying that this portion only they need. This portion only they need. Exactly A. Okay. Sorry, I think the full portion. Full portion, sorry. Full portion A. So yeah, full of A. Haan, correct. Correct. Okay. So what we are saying, we need just only A. So if we need only A, so first what we have done, we have added all of the 3 probabilities, PA, PB, PC. So if we are adding all the possibilities, that means we have added all of them. Then what we are doing, we are subtracting. What we are subtracting? We are subtracting first of all 2 times of A intersection B. So this part is gone. Okay, this part is gone. Then 2 times of B intersection C. This part is also gone. Sorry, circle is already gone. 1 second. Okay, this part is also gone. Then it is saying C intersection A. C intersection A means B intersection C. Okay, this is, let's say this is B intersection C and this is C intersection A. So this is gone, right? And then they are adding 3 times of A intersection B intersection C. A intersection B intersection, that is they are adding this portion. Actually if you subtract 1 time, then only this portion will go, but they are subtracting 2 times, so this portion will also be covered, right? So this total A we need actually. So I'm just discussing about the A only. So this total A will be by this formula you will get. And why this 3 times has been added? Because one time A intersection B intersection C is subtracted from here, because A union B, A intersection B is considering this common portion between all of them also. So if 3 times you are subtracting, that means 3 times you have to add that common portion between all of them. Alright, if you understood it, then it's okay. Otherwise, please revise that again from your set theory chapter. Okay, similarly, if at least 2 is given, at least 2 of A comma B comma C occur. At least 2 means minimum 2, more than that 3 can also occur. So minimum 2 means you are adding the common portion between all of them first of all, then subtracting 2 times of A intersection B intersection C. Why 2 times? Why not 3 times? Because we are saying that 2 should occur at least. At least 2 should occur. Okay, so if you understand like this, we are adding all the 3 portions, common portions, and then we are subtracting 2 times the common portion between all of them. 2 times, why? Because 3 times it has been added. 3 times it has been added, so at least 1 time should be, 3 times, 3 times it has been added. 3 times of P A intersection B intersection C is already added here. So if we subtract 2 times, then we will get 1 time here. So 1 time means probability of intersection B intersection C. Then only we can say na ki at least 2 of ABC can occur, means this portion. Let's say if A and B we are saying that, so let's say this portion will occur, at least 2 of ABC occur. Then if exactly 2 of A comma B comma C occur, means exactly means now they are specifically saying, okay, that means they don't need the common portion. So that's why they have subtracted total common portion 3 times. Why? Because 3 times added here. It is 3 times added here. Right? Yes, tell me, Dhyan. At least 2 means minimum 2 should occur. Maximum it can be 3 also. Okay, minimum 2 should occur, maximum it can be 3 also, but exactly 2 means specifically 2 probability should occur, 2 events should occur. Okay, that's why they are subtracting 3 times. Why? Because they don't need this common portion. They don't need this common portion. This common portion they don't need. So that means they are needing only this portion, or either this portion, or either this portion. Getting this point?
Okay, so that means that the intersection part should at least means that they are making
They
the
are
intersection part.
they are getting one intersection part for them, but in the exactly they are not getting anything, any intersection common part between all of them. Okay,
Now it's clear.
next is the question based on this. It is saying that events are mutually exclusive. I explained you what was the mutually exclusive means. What is the meaning of mutually exclusive? Means nothing is common between the in the events. Nothing is common between the elements. So probability is given as, probability of A is given as 1 plus 3x by 3. Probability of B is given as 1 minus x by 4. And probability of C is given as 1 minus 2x by 4. Then it is asking that the set of possible values of x lies in the interval. Set of possible values of x lies in the interval. Okay, let's discuss this question because we have less time now. And yeah, so you know that if a probability is occurring, suppose if a probability is occurring, now mutually exclusive means there is nothing common between all of them. There is nothing common between all of them. All right, so if we say this probability is occurring, it means that probability of A should be greater than equal to 0. Similarly for probability of B also should be greater than equal to 0, and similarly for C also this should be greater than equal to 0, right? So 1 plus 3x by 3 is greater than equal to 0. From here you can find out the x value, that will be coming as minus 1 by 3. Similarly from here you will find out the x value, 1 minus x by 4 is greater than equal to 0, and when you find out from here x, x value will be less than equal to 1. Okay, inequality will change because negative sign has to be multiplied both side. Those things you already know. I am assuming that you can solve these inequalities, right? 1 minus 2x by 2 is greater than equal to 0. 2 will go to 0 denominator part, and then x will be simply nothing but less than equal to 1 by 2, right? So this is your first equation, or we can say inequalities. This is second, and this is third. Okay, and one more thing, that is total possibilities. Sorry, total. If we add all the events, what should be the total probability? It should be one only. So it means probability of A plus probability of B plus probability of C should be less than equal to. Sorry. So that's why I'm using. So that's why I'm using inequality, na. That's why I'm using inequality. Okay. Yeah. So therefore, 1 plus 3x by 3 plus 1 minus x by 4 plus 1 minus 2x by 4 is less than equal to 1, and I am hoping that this is the simple algebra you can solve, and this will give you the x value, which is nothing but greater than 1 by 3. This is the fourth equation. And what is the next step? Just see that whether in which portion it will lie. So x should be greater than 1 by 3. Yes, yes, tell me. After this third equation, yeah, I was saying ki the total probability, that means the sum of the total events, or we can say the probability of all the events, if you add them, it is 1. So the the Sujit was asking that, they are not exhaustive events were those events in which if we add all the probabilities, they should be equal to the uh, total probability, that is 1, right? Maximum probability. So since it is not equal to 1, because it is not said that exhaustive, so that's why we are using the inequality here. Okay, less than equal to 1. All right, so I think you can calculate now. So 1 by 3 to 1 by 2 should be the answer. Okay, only one option is there, the first option. By considering all the four equation, if you see, you will get the answer, that is first option. Is that clear? Next question. Next question is the last question. I can give you the homework. Acha, how we are getting this x 1 by 3 to 1 by 2? Actually, you can take the common portion by representing them on the real line. Okay, so this is minus 1 by 3 somewhere here. Let's say this is 1 by 2, this is 1, and this is 1 by 3. So 1 by 3 is 0.33, that is somewhere here. So the question is saying greater than 3 by 3, so that means this is the portion. Then it is saying all of them are less than, so let's say this is the less than, then less than this, and less than this. So you can see the maximum, the common portion between them is nothing but lying in this zone only. So the answer should be lying in the 1 by 3 to 1 by 2, first option. Right, so the first option is the correct answer for this question. Now this is the last question. Okay, and just 1 second, I'll just edit here. Actually they have given here the complement. Okay, this is complement is given, and they are asking the P B intersection C, right? So will you try? I'm giving you to try this question as homework. Okay, if it is not done, I will send you the solution in the group. All right, just let me know. So that's it for today. If you have written this, that's it for today. And the answer for this question, 1 second, answer is A only. You can take the answer also, 1 by 12. Okay, so hope you all enjoyed it. Thank you, and till then we will meet in the next class then. Bye. Okay.